let's see if we can prove this, or at least kind of sketch how you might prove it.
Good P alpha.
P alpha. Yeah.
P alpha.
What's an alpha? All right. My alpha is really generating here.
Sometimes when you write your text.
I know. I do this.
Yeah.
Okay. Now this is okay. So linearity in the interval of integration. Let's think about this. You know, a really weird thing? If alpha is x and it's a Riemann integral, this is a theorem, it's true. But unless we place some conditions, in general, it's false. I have an example I worked out long ago.
The power went out there, but it's out here. That's strange. But all the hollows is
Really, maybe we're on generator or something, and that's not priority. Okay. I'm going to define f of x to be the following. It's 0 if x is between 0 and 1. 0 included 1x excluded. And it's 1 if x is between 1 and 2, both included. And the weight function is going to be 0 if x is between 0 and 1 included, and 1 if x is strictly greater than 1 less than 1. Huh? Oh, this is one of these diabolical examples. We want to show the following things. We want to show that the integral from 0 to 1, the Riemann-Stieltjes integral from 0 to 1, f d alpha equals 0. We want to show the Riemann-Stieltjes integral from 1 to 2, f d alpha is 1. And we want to show the Riemann-Stieltjes integral from 0 to 2, f d alpha does not exist. Okay. Okay. So that's the definition of the function. It's kind of hard to draw. Let me try to make a consistent drawing. With the same y-axis, this will be f and this will be alpha. So here's 1 and here's 2. So f
function is not our
these. Okay,
Right.
yeah. Okay, let me draw the graphs. You can't see everything here. Let me draw the graphs in front of you. So f is going to be there, and then pick up and go from there to there. Alpha is going to be from here to here, and pick up and go to here. Okay? So we want to form 3 Riemann-Stieltjes sums here and show that in the first 2 instances we can approach a limit, but at the third case. All right, why's that? Good. Business about a constant alpha. This integral is weird. It's like nothing much happens except for here. You know, this is the kicker. Delta alphas out here are all 0. Delta alphas out here are all 0. So, no matter how you partition it, the very last little rectangle is going to, in this case, have 0 height, right? However, also, there won't be any alpha. You know, all the delta alphas are going to be 0. And F, if you picked this point to be the tag point, you picked 1 to be the tag point, then F would be 1 unit high, but you'd still, the delta alpha that goes with it is 0. So the contribution is going to be 0, right? No matter what. Except for that last rectangle. The delta alphas are all 0 and the F's are all 0. Your only hope of having anything in the first integral, that would be this integral, right? The only hope for that one would be to have alpha jump up at the same time. So the delta alpha and F were both 1 together, but they're not. Right? The delta alphas from 0 to 1 are all 0, so you're not getting anything out of that. So I think we've proved this, at least to my satisfaction. Are you happy with that? And delta alpha is identically 0. The weight function is a constant. The entire integral of integration, so we've already proved that that's 0. Okay. How about the second case? If I go from 1 to 2, from 1 to 2, what happens? Well, F is constant 1. So whatever a delta alpha gives us, times 1 is what that integral is going to be. Alpha is a constant for all of the little delta alphas to the right of 1. But alpha of 1 is 0, and then the alpha of x naught is 0. Alpha of x1 is 1, right? It's the leftmost partition element. You know, doesn't matter how we squeeze this down to hardly anything. The left endpoint of that baby is at 1. So alpha of 1 is 0, and then the right endpoint for alpha is at 1. So you're going to have a contribution of 1 to alpha times the 1 of F, which is constant, in the closed interval 1 and 2. So this integral is going to be 1. It gets its entire value from the phenomenon of alpha jumping 1 unit while F is 1. You multiply those two things together. The F, which is 1, and the delta alpha for the leftmost partition element is 1. And all the other stuff doesn't amount to a hill of beans, right? Okay. So those two things are true. Why is it then that the third integral doesn't exist? If I go all the way, okay, nothing much happens when alpha is constant. So it has to be the way the partition falls with respect to 1, right? Well, what makes the integral not exist? Doesn't approach a limit. What makes it not approach a limit? Given two partitions with small norm, right? Small norm, they're not close. Remember, that was our condition. You weren't here on Tuesday, but the Riemann integral, also for the Riemann-Stieltjes integral, is that if you squeeze the partition norm down, what you want to have happen is for the sums, it'll always be close. And given any epsilon, I can make any two sums close if I just refine the partition so the norms get
Again, no
smaller.
matter which